let us just look at these three ideas of union, intersection, and complement, and see how they would relate to another subject. Now, you probably have done the logic gates in information technology. All right. Now, the union would represent R in information technology, because A union B is represented by those in A alone, those here is representing A alone, or B alone, or both. So in the logic gate, when you have any one of the input is a 1, then the output is also a 1 instead of a 0. And in other words, when any input is high, the output is also high. All right. If you don't know about that, it would be good to read upon, because anyway, you will be doing information technology as well as a subject. But the union, it represents R in logic gates. So A union B, it's like A or B. We're saying A or B. All right. Now, A intersect B, it's like the AND gate. You can compare it to the AND gate. Both input must be high for you to have an output that is high. If one input alone is high, the output is still low. If in the logic gate, if only one input is a 1 and the other is a 0, the output will be 0. The output is only 1 if all inputs are 1. In this case, it's AND. And of course, the intersection here would represent A and B. A intersect B. Alright? So, you can represent this by saying A and B. Let me get my colors brighter. A and B. So, that's what intersection represents in the logic gate, A and B. Now, the complement here would be presented by what is outside of A. In other words, what is not in A. So you can see that that is comparable to the NOT gate. You have an input that is high, the output is low. Input low, the output high. Alright? In other words, if the input is 0, the output is 1. If the input is 1, the output is 0. Alright, so this really means not A. So because it's representing a NOT gate, not A. Alright, but as I said, if you haven't done logic gates yet, it's an interesting topic to read upon. You can compare it to an electrical circuit also, where the R would be represented by a parallel circuit and the AND represented by a series circuit. Alright, so it would be good for you to read upon if you don't know it, if you haven't studied it as yet. Alright, so we'll break at this time, and I will see you in the next video.